All right, so I'm going to do one of the problems from the worksheet. So you've got 4 different types of atoms here, and these are the amounts of all the 4 different types of atoms. So the first thing that we've got to do is figure out the mass number for all of these. And so remember that the way that you figure out mass number, it's the number of protons plus neutrons. So even though we're given the number of electrons here, that doesn't affect the mass number. So for this one, it's 32. For this one, 33. All right, notice that for this particular element, there would be no such thing as an atom having a mass number of 35. Okay? So the second thing that you've got to figure out is the percentages. The information that's given to us here doesn't give percentages, it gives quantities. Okay? So if we want to calculate percentage, the first thing that we've got to do is figure out what is the total number of atoms here. And if you add up all those numbers, it comes up to 11,977. Okay? So to figure out what percentage of the atoms are this particular variety, the mass number 32 variety, what you would do is do the part divided by the whole. The part is the 11,400. The whole is going to be the total. Okay? And you can work out the percentage for the rest of these doing the exact same thing. So when I do that for the rest of these atoms, these are the fractions that you would have. And if you did the math, these are the numbers that would pop out of your calculators. All right? Notice there's a lot of digits here. So in order to make this a little bit more simple, what I'm going to go ahead and do is take these decimals here and round them to 3 significant digits. So these are now the percentages represented as decimals. Okay, notice it's not the same thing as a percentage. This right here, if it was a percentage, would be 95.2%. This would be 0.701%. All right, but since we're going to be using the percentages as decimals in the calculation, I'm not going to bother turning these into percentages. So after calculating these percentages as decimals here, we're going to take them and we're going to put them into that formula, where what we're going to do is take this percentage as a decimal right here and multiply that by the mass number. So that we're going to add this percentage as a decimal by the mass number, and so on for all the rest of these different isotopes. Okay? If you do the multiplication on that, that becomes that, that becomes that, that becomes that, and so on. And notice as of yet, I'm still just writing down all the numbers. When I add those together, what comes out of my calculator is this. So the way that you want to round this is at this position right here. And so if you round at that position, phi says round up. So I would report my answer like this right here. Don't spend too much time thinking about the rounding. If you put 32.09 on your paper for this particular problem, I would give you credit. But just realize that in general, atomic masses are rounded 2 places after the decimal. One other thing to notice is just to make sure that your answer makes sense. All right? When we take a look at all of the different mass numbers that we had here, you would realize that before we even started, what should our answer be? All right? We know that it's going to be between 32 and 36, but if you look at these amounts right here, this tells you that the average mass number should be closer to 32 than it would be to 36, and that's consistent with the answer that we get.